Okay, kids, Charlie Abuso here. I'm your chemistry teacher. Hello. Nice to meet you finally. This is the final naming compounds review. This is called what I call the master set. This has got the hardest of all the names. They're not hard, honestly. The rules are easy. Keeping track of which rule to use. Is it a simple monoatomic ion formula? Or is it a transitional metal? You need a Roman numeral, or you don't need a Roman numeral. Or is it a polyatomic with table E and a combination of the others? Or is it two polyatomics, cation and anion? Or is it a molecular compound? Keeping track of which rules to use is harder than the rules themselves. So you have to think. If your first name or your first symbol is a non-metal, that makes you molecular and you use the prefix naming system. If your first name is a metal, you got to say which kind. If it's in group 1 or group 2 or group group 1, group 2, or aluminum, this is the simple monoatomic cation business, and it's either a +1, +2, or aluminum's +3. If it's a transitional metal from group 3 to 12 plus the triangle elements, I call them under the stairs, it's a little triangle shape under the stairs, then you probably need a Roman numeral. Most of them need Roman numerals, but not all of them, right? Zinc, for instance, only makes it +2. You don't get a Roman numeral. And then, of course, there's table E. Table E's got 22 polyatomic, small groups of atoms bonded together that either lose or gain electrons, and we never change those names. So there's a bunch of rules. That's the trick here. Which rule are we going to use? We're going to go relatively quick. I'm getting close now. I want my periodic table in hand. I moved it for a second and I wanted it back. So now I'm ready. What is the name of this compound? CO. CO, put your finger in box number 27. CO is a metal. CO is a transitional metal. CO is cobalt. Cobalt makes two different ions, Roman numeral 2 and Roman numeral 3. OH is hydroxide on table E. So we have 3 hydroxides here and only 1 cobalt. So since the hydroxide's a -1 and the cobalt could be 2 or 3, this in fact is going to be cobalt Roman numeral 3 hydroxide. And of course it's ionic because cobalt's a metal. There you go. Uh-oh, there's a doozy. I like that word. Actually, it's not a doozy, it's a 7Z. Mn is element 25. Put your finger in the box. Makes 4 different cations. In fact, it even makes one that's +7. Look, there's a 7. We have 7 of those NO2s. On table E, remember NO2, or you see, put your finger in the box there, nitrite. So we got some sort of manganese nitrite. How many nitrites do we have? 7. So we have manganese, Roman numeral 7, nitrite. That's the biggest Roman numeral we have. Roman numerals go almost forever, I suppose. But actually, that's a good question. I don't think they go forever. I'm not sure those Romans counted after a certain point. I will have to ask a math teacher, what is the highest Roman numeral? Because back then, there was probably no need to count to millions or billions. I don't know if there are Roman numerals that go that high. Wow, I never thought of that. Roman numerals might come to an end. Well, we only have to get to 7, and that's this one. Wow, Mn with MnO4. This is going to be fun to say, right? And we need 7 of them. Now, MnO4 on table E is called permanganate, and it's a -1 ion. That's why there's only 1 manganese in the front. But we need 7 permanganate, so that means it's a +7 ion again. So this is manganese Roman numeral 7 permanganate. There's a lot of letters in that name, but this is not hard. You just have, there's the bells, I'm still in school. You have to just go slow and you can't miss them. SiO2, we did this a few times. This is a good one. This comes up on the Regents a lot because you know what? Because you go to the beach. The beach is a good place to go. Some of you, I don't know, put it in your garden, you mix cement, you have to have sand. SiO2. Si is silicon with 2 oxygens. It's molecular, so use prefix names. Silicon dioxide. It's a molecular compound, okay? Non-metal, non-metal. HCl. You're going to learn this better when we get to acids and bases. When we put this stuff in water, we call it hydrochloric acid. But right here, it's not in water. There's no AQ. This is probably a gas right now, right? Hydrogen monochloride, non-metal. We use the prefix naming system. Say the name of the first atom, unless it's a multiple, it's not, so we just call it hydrogen. And the second name always gets a prefix. This looks like Zorro. Zorro was a TV show when I was a kid. Zorro wore a black mask and he had a sword and he would defend the rights of the poor and against the bad guys. Zr is zirconium. Zirconium is element 40. It's +4 and oxygen's a -2. Well, this one's tricky, right? +4, -2. It should be in a 2-to-4 ratio, but it's in a 1-to-2 ratio. And we don't need a Roman numeral because zirconium only makes one kind of ion. It's ionic and it's just called zirconium oxide. No Roman numeral needed. Ba, element 56, barium. And then we have 2 hydroxides there. Hydroxides on table E. Barium's a +2, cation ion in group 2. Hydroxide's a -1, so it's going to be just called barium hydroxide. Barium's a metal also, so it's ionic. Barium hydroxide. That even looks weird, right? HF. What the heck is HF? Where did he get HF? Put your finger in the box. 72. HF's an element. Look it up on table S. Look, it's right down here. Find it. It's got a funny name. It's not like fullium. It's hafnium. Half. It's really not half. It sounds like that. Hafnium. Now, hafnium makes a +4 ion, just like zirconium above it, right? No Roman numeral needed. And it's going to be a +4. We have 2 negative sulfides, so it's just going to be a 2-to-4 ratio, which John Dalton said 1-to-2 again. I don't know which way my hands go. It's a 1-to-2 ratio. It's ionic because hafnium is actually a metal, and it's called hafnium sulfide. No RN needed, Roman numeral. Listen, if you see some letters you don't recognize, you got to look. But if you only have to look for one, you're not wasting a lot of time. If you're going to look for 20 or 30 different answers, you're wasting a lot of time. You're going to get all anxious. You're going to be upset it's taking you so long. If you put some time in and learn the dang periodic table a little bit, if you knew most of it, you'd spend a lot less time doing this. I like this one. This is a common solution. When you put this in water, this turns into a solution. We use this a lot in chem lab. Ag is silver, number 47. It's a metal, so this is ionic. And NO3 is on table E. It is called silver nitrate. Silver nitrate. This would be a white crystal powder because it doesn't say AQ. If it was AQ, it would be dissolved. It would just look like salty water, but it would be poison. Don't drink it. BCl3. Now make sure you don't see this. It's not BCI3. That's an L. Sometimes they're hard to tell, but it's BCl3. B is number 5. It's a non-metal. Boron rhymes with boron, 3 chlorines. Molecular boron trichloride. There it is. Rhymes with. There's the bells again. My mouth is going to water. You guys know who Pavlov is? Pavlov. Pavlov and his dogs. Look that up. My mouth is watering, and you'll laugh when you read it. INPO. No. IN. Element number. What do we got? 49. I was element 49 once, but now I'm about to be element number ND. Indium. Indium makes a +3 ion. PO4, indium's a metal, so PO4's got to be a non-metal. It must be a polyatomic anion, and it is. Indium phosphate. We don't need a Roman numeral because indium only makes a +3 ion. So it's not indium Roman numeral 3, it's just indium phosphate. Indium is back. Indium is in as opposed to not being cool. Now it's the in metal. Indium, which has a +3 ion, and CO3 has to be an anion. It's on table E, called carbonate. Carbonate is a -2 ion, so the 2 goes for indium, the 3 goes across, and it's called indium carbonate. We don't need Roman numerals because indium only makes a +3 ion. Carbonate's a -2. Crisscross becomes a 2-to-3 ratio. IN2, carbonate 3. SNF2. SN, element 50, makes a +2 or a +4 cation. Got to have a Roman numeral. SN, you guys remember what SN is? He was in Wizard of Oz. He's not the Scarecrow, and he's not the Cowardly Lion, and he's not the Wizard. He's the Tin Man. Tin Roman numeral 2 fluoride. Has to be a positive 2 because the fluorines are both -1. You got 2 -1s, and you have 1 cation. It has to be a positive 2. Look at this. It's the other one. Here, we got tin with 4 fluorines, 4 -1 fluorides. There's only 1 positive 4. So this is tin Roman numeral 4 fluoride. See how tin and fluorine, they make 2 different ionic compounds, but they're not both tin fluoride. You got to tell them apart by using the Roman numeral. Fe2O3. It's better to burn out than it is to rust. That's a song, Hey Hey My My by Neil Young. It's better to burn out than it is to rust. That's the formula for rust, when iron turns to rust. Fe2O3. In this case, if you put your finger in a box for iron 26, it's either +2 or +3. The oxygen's a -2. Now, if you start out -2 and positive and crisscross, that's what you get. That 2 there comes from the oxygen. That means this is Roman numeral 3. If you don't get that, and it's okay, maybe you just don't understand this uncrisscross business. Iron only makes 2 ions. Do them both. Fe +3, O -2, that works. But what if you tried the other one? Fe +2, O -2, 2 to 2 means FeO. This is not FeO. It has to be the Roman numeral 3. There's never a problem. If you can't figure it out, just do all the ionic compounds possible and figure out which charge you used. That's the Roman numeral to pick. Here's the other one. If iron makes a +2 ion, oxygen's always a -2. It's a 1-to-1 ratio. This is called iron Roman numeral 2 oxide. This is not your normal rust. Regular rust is the other one, Fe2O3. CaS, calcium, Charlie Abuso. Ca is a +2. Sulfur is a -2. Calcium, you drink it because you're drinking the ions. You're not really drinking a metal, but it's a metal, so it's ionic, and this is just called calcium sulfide. Simple monoatomic ions bonding together. KCN, different than KFC, right? KFC is probably a lot of chemicals. You shouldn't eat that stuff, but KCN, K is potassium cation. Metals bond with nonmetals. In this case, it's polyatomic. You got to look this up on table E. Cn happens to be a -1 anion called cyanide, potassium cyanide. Don't eat this. The side effect for potassium cyanide is instantaneous death. It's very hard to reverse that. This reminds me of the movie The Princess Bride. He's only merely dead. He's not completely dead. I've seen worse. But if you eat this stuff, there's no fixing it. Stay away from it. More cyanide. Stay away from this too. Here is aluminum. Aluminum's a +3. Cyanide's a -1. So here we need 1 aluminum, and you got to triple up on the cyanides. But we don't use prefixes because it's ionic. Aluminum, cyanide. That's all you got to say. More cyanide. I must have been having a bad day when I made this slideshow. V for vanadium. Put your finger in box. What do we got? Box 23. Vanadium makes a +5 ion, and that's required here because we got 5 -1s here, 5 cyanides. We got to have 1 +5. Vanadium, Roman numeral 5 cyanide. That's kind of cool. Vanadium, Roman numeral 5 cyanide. Is a quick thing. See the formula on top? That V stands for vanadium. It's not Roman numeral 5. Don't ever put Roman numerals in the formula. The Roman numerals are for the name. The name tells us which ion it was. From the formula, you only have to be a little smart. It must be the +5 ion because you got 5 -1s. What else could it be? You don't have to tell us twice. But in the name, you could have had what? Vanadium Roman numeral 2 cyanide, vanadium Roman numeral 3 cyanide, vanadium Roman numeral 4 cyanide, or in this case, vanadium Roman numeral 5 cyanide. In the name, somebody just texted me. One of my closest friends just said, there's 4 pieces of crumb cake in my mailbox. This guy loves me, and I love him. He's fabulous. He's a great cook. The crumbs are so big, I think my mouth is watering, and I can't wait to get home. The heck with Chem. I want to eat crumb cake. SO3. S, sulfur, is a nonmetal, element 16. So this is a molecular compound, and we use prefix names. One sulfur is just sulfur, 3 oxygens, trioxide. Some of them are easy. You're getting so smart. You knew this. You knew this. Uh-oh, FBR. Fluorine is a non-metal, element number 9. This is a molecular compound. The second name you're going to be casual. Fluorine bromide. Don't be lazy. Second name always gets a prefix. Fluorine monobromide. Got to follow the rules. It's not your game. It's my game. It's this. We got the rules to follow. We can't do what you want to do. You got to do what I tell you. Fluorine monobromide. Oh, snap. Look at all those numbers. Iodine 4 times. Now, we don't change the first name. We just put a prefix on it. Tetraiodine. I don't even know how to say this one, right? 9 chlorines, nonachloride. Yeah, that's a hard one. Tetra, now that dash there, tetraiodine, I put that in so you could see it, but it doesn't belong there. It's okay. It's a minor glitch. Tetraiodine, but technically there's no dash. It's one big word, tetraiodine, nonachloride. Hey, we're masters now. Look, I'll make it close again. We're masters. You guys did this. You did all of these, I hope. Hopefully, you can name compounds. It takes practice. Really? You still got to look at this. You still got to look at this. The more times you look at this periodic table and you begin to say, I know where gold is, 79. I know where iron is, 26. The more you don't have to memorize it, but the more you get familiar, you look quicker. You'll become more familiar. You'll get better at it. You'll be quicker at it. The rest of your life will be easier. When you're spending a lot of time looking for stuff, you're getting anxious. You're running out of time. You're getting mad. You want to go out. You want to go have some fun. You want to go out and look at the sky, like I tell you right now, in a minute. Go out and look at the sky, even if it's raining. It's a little cloudy right now, but I'm going to go bike riding later. Go be freaking alive. Chemistry is important, but it's not the most important thing in your life right now. Stay healthy, stay smart, be happy, be good to old people and dogs. And I don't care if you're nice to cats or not. Don't be mean to them. Just be indifferent, because they're kind of indifferent to you too. I'm sorry. What is it? Angelina, I think. I'm sorry. All right. You kids are like cats. You're all good people too, no matter what I say about you. Stay out of trouble. Be happy. Do chemistry as often as you can, but do other stuff. Walk. Talk to your parents. Talk to your siblings. Call your grandmother. Write somebody a letter. Bake cookies. Whew. Goodbye. I've had a good time today.